The recent tensions between the United States and Iran are driving fuel prices sharply upward. As a result, electric vehicles are increasingly seen as a way out. But how are they actually made? And is this truly a sustainable solution, or just another problem being hidden beneath the surface? Behind every electric vehicle lies a complex manufacturing chain. This process is not just about technology, but also a global race for resources, energy, and industrial scale. In this video, the Factorin takes you deep inside the full production process of an electric vehicle, from raw materials to the moment it rolls off the assembly line. The global electric vehicle market has now surpassed $388 billion, making it one of the fastest-growing sectors in modern industry. Alongside this economic scale comes a surge in production worldwide. In 2023, more than 14 million electric vehicles were sold globally. In this race, China currently leads in both production volume and market expansion speed, driven by its strong supply chain, advanced battery manufacturing capabilities, and ability to optimize costs at massive scale. In the United States, Tesla has emerged as a symbol of a different approach, one focused on technology, performance, and user experience, and unmistakably a high-tech product. So what about you? Do you lean toward the technology-driven approach from the United States, or the large-scale manufacturing power of China? What defines an electric vehicle? Advanced software or massive metal structures weighing tons? In reality, everything still begins with a familiar material: steel, shaped through the first stamping and forming processes of the car body, at facilities like Ford Cologne and BMW Dingolfing. Coils of high-strength steel and aluminum are fed into large servo-stamping systems. Each press can generate up to 6,000 tons of force, enough to transform a flat sheet of metal into body panels, door pillars, or floor structures within seconds. A complete stamping line can process more than 10,000 parts in a single 8-hour shift. Before stamping, the metal is cut into individual blanks, then automatically fed into the dies by robotic systems. Sensors continuously monitor pressing force, position, and material deformation throughout the process to ensure each component meets its exact design specifications. Right after the body components are stamped, the robotic spot welding system comes online. Human-height robotic arms equipped with resistance welding guns move along pre-programmed paths to join metal panels together. Each weld takes only about 0.5 to 0.8 seconds, fast enough to create thousands of joints in a very short time. Large panels such as the floor, side sections, A-pillars, and roof frame are secured in jigs using locating pins and hydraulic clamps to maintain precise positioning. Robots carry out the welding in sequences, while sensors continuously monitor clamping force, electrical current, and contact position to ensure consistent and stable weld quality. A fully automated welding line can complete 60 to 80 vehicle bodies per hour, producing a unified frame with high structural strength and dimensional accuracy. As soon as the body frame is fully assembled, an optical robotic system begins geometric inspection. Mechanical arms move in coordinated motion around the vehicle, projecting blue laser beams to scan the entire body surface. Every weld point and every curved panel is captured with extremely high precision. Each movement is programmed as part of a synchronized mechanical sequence, allowing the collected data to accurately reveal any deviations if present. The results are analyzed instantly to verify whether the body structure meets engineering specifications. This step is critical, ensuring consistency across all downstream stages of the production line. At the next stage, The bare steel frame receives its first protective layer, an anti-corrosion coating. To achieve this, the entire body is submerged in an electrophoretic coating bath, a water-based epoxy solution carrying a negative charge. Under the influence of electric current, paint particles migrate and firmly bond to the positively charged metal surface. This electrochemical reaction creates a uniform coating that penetrates deep into every corner, including areas that traditional spray methods cannot reach. Robotic systems rotate and tilt the body along multiple axes to ensure complete coverage with no missed spots. Suspension bars and support frames carry heavy loads while operating reliably in a humid, high-voltage environment. The result is an invisible protective layer that shields the vehicle frame from environmental damage throughout its lifespan. The entire process acts as a chemical cleaning stage, removing residual contaminants while preparing the surface for the clearless.
Next, layers of paint.
Once the surface has been cleaned and stabilized, the body is transferred directly to the paint shop. Here, the automated painting process begins, where color is not only about appearance, but also serves as a second layer of protection for the entire body.
Typically, a vehicle receives 3 layers: a primer to enhance adhesion, a base coat for color, and a clear coat on top to protect against scratches, chemicals, and UV exposure. Each layer is applied by robotic systems equipped with high-speed rotary atomizers, spinning at tens of thousands of revolutions per minute to create a fine mist that evenly covers the surface. By the time the vehicle leaves the paint booth, it carries a new finished design to look refined, remain durable, and withstand both time and environmental conditions. At this point, think back, the last time you bought a car.
Did you choose the color based on personal preference, family opinion, or a promotional deal?
After the final coat is applied, the body moves into surface finishing, where the mirror-like appearance begins to take shape.
Polishing heads carefully work over each section to remove paint dust, contaminants, and minor imperfections. Next, an automated polishing system operates with programmed speed and pressure,
using rotating pads to refine the surface until it reaches the required level of reflectivity. Hard-to-reach areas,
such as door edges, are handled manually with handheld tools and inspection lighting. The entire vehicle must achieve uniform light reflection,
meeting the visual and quality standards expected from the entire production line.
The mirror-like paint finish is only the beginning, because the core of an electric vehicle lies beneath the surface. The electric motor. Instead of relying on fuel combustion, the motor generates torque almost instantly through the interaction of magnetic fields and electric current, delivering fast and stable response from the moment the vehicle starts moving. The manufacturing process begins with the stator, the stationary part, where copper windings are precisely wrapped around an electrical steel core,
a material designed to conduct magnetic flux efficiently while minimizing energy losses.
These windings are insulated with specialized coatings to withstand high temperatures and continuous electrical load. Next comes the rotor, the rotating component, typically fitted with permanent magnets made from rare earth alloy,
such as neodymium, enabling strong magnetic fields within a compact structure. The rotor is carefully machined and dynamically balanced to ensure smooth rotation at high speeds without vibration.
As the rotor descends, the magnetic pull increases. We use the hydraulic lift for a controlled placement, fitting the shaft precisely into the center of the stator, or lightweight alloys, to improve heat dissipation and reduce overall weight. Inside, position and speed sensors are integrated
to allow the electronic control system to monitor and adjust current flow with millisecond precision.
Cooling systems, either liquid-based or air-based, are designed to maintain stable operating temperatures throughout use. Power for the entire system comes from a lithium-ion battery pack mounted beneath the vehicle floor, made up of thousands of individual cells, arranged into modules in a complete pack. Before installation, each motor undergoes rigorous testing, including efficiency measurement, vibration analysis, and performance runs across multiple speed ranges to ensure reliable operation under real-world conditions. Beneath the smooth, mirror-like metal exterior, the drivetrain and battery function as the central nervous system that determines the performance of an electric vehicle.
The process begins with mounting the motor assembly onto the rear axle, connecting it to the drive unit and differential.
Through mounting points aligned with high precision at every contact surface. The battery pack, pre-assembled with an integrated battery management system, ensures that all cells charge and discharge evenly without exceeding safe temperature limits. A liquid cooling system runs tightly along the battery through sealed channels, efficiently dissipating heat. High-voltage cables, charging ports, and power converters are all insulated to resist electromagnetic interference and withstand high temperatures. To unite the body and chassis, the factory uses an automated assembly system with specialized lifting platforms. From two separate conveyor lines, the chassis slides in from below, while the body is suspended by hydraulic lifts capable of handling loads of up to 2 tons. As the body reaches position, laser sensors align it across 3 spatial axes. Robotic arms with articulated joints automatically adjust the body, so that connection points match precisely with the structure underneath. At the same time, electrically actuated robots connect the main high-voltage cables, linking the battery, motor, and control systems inside the cabin. The once empty cabin now becomes the main stage for some of the most precise interactions between humans and machines. Interior installation. Seats are placed using multi-jointed pneumatic robotic arms that can rotate along multiple axes to position the frame accurately. Once lowered into place, workers secure mounting clips, heating wires, and safety sensors by hand, then verify alignment using handheld laser tools. The area in front of the steering wheel is the most carefully adjusted section. The central display, dashboard, and touch controls are installed with extremely tight tolerances. Assisted tools apply controlled torque to fasten each component, preventing cracks or damage. Next, the vehicle enters final assembly. The windshield is installed using vacuum-assisted robots, with sensors aligning the angle while adhesive is applied. And the glass is pressed into place. Doors are positioned by robotic arms as hinges are aligned and bolts secured. Side mirrors are installed with torque-controlled tools to avoid surface damage. At the wheel station, operators center the wheels, while machines tighten lug nuts in a star pattern. Smaller parts like badges, antennas, and trim are added last,
using laser-guided positioning for consistent alignment. Before it can leave the factory, every vehicle must pass the final inspection and testing stage. The car is placed on a conveyor, where technicians check the brakes, lights, steering, noise levels, water sealing, and throttle response. It is then driven through a simulated test track, featuring a range of conditions, including slippery surfaces, inclines, rough roads, and emergency braking scenarios. Only after passing every test is the vehicle approved for release. Although the vehicle now has its full physical form, it is still missing a critical element: the intelligence that brings it to life. At a dedicated technical station. For markets like the United States and Europe, the software is specifically configured, supporting
over-the-air updates and adapting to driver behavior over time. It is at this stage that the electric vehicle transitions from a mechanical machine into a fully integrated technological system. Not every vehicle leaves the factory in the same direction, but all of them begin at the outbound area. Each car is scanned, labeled, and covered with protective film. From there, vehicles are loaded onto transport ships, then moved by truck to dealerships. Throughout the journey, everything is tracked in real time to ensure each customer receives the right car at the right place at the right time.
From raw metal and copper coils to a fully assembled machine powered by software and electricity, an electric vehicle is the result of a global industrial system working in perfect coordination.
Every stage, from stamping and welding to battery integration and final testing, reflects the scale, precision, and